The question asks, an open flask partially full of liquid water is heated to boiling and promptly capped. Cold water is poured over the top of the flask. The water boils even more vigorously. Explain. This phenomenon occurs because of a couple different principles. The first principle we have to understand is the definition of boiling point as it refers to vapor pressure. So vapor pressure is the pressure that vaporizing particles, molecules of water in this case, when they reach equilibrium with the atmospheric pressure. In other words, as a liquid is existing, the molecules are all moving at different rates. Now the average is such that they're staying in solution, but some of them have enough kinetic energy that they're going to break free from the liquid in the form of gas. This is evaporation. Now, in a closed container, there's air within a gas, air is in this case, within the container that is putting pressure down upon the liquid as well. And so the water is going to vaporize at such a rate, and it's going to condense back down at such a rate because of the atmospheric air pushing on top of it. So when the rate of molecules escaping the liquid and the rate of molecules condensing back into the liquid is equal, that is defined as the vapor pressure. And so that's a result of the atmospheric pressure, all the particles moving around, bouncing around, keeping that pressure on the liquid. And so when heat is applied to a liquid, heat is directly proportional with kinetic energy or velocity in this case. And so when heat is applied, the molecules move more rapidly. And when it is that the vapor pressure equals the atmospheric pressure due to boiling, due to heat being added, that is when a substance or liquid begins to boil. When the energy within the liquid is such that the vapor pressure is equal to the atmospheric pressure. So that's when it all starts to become a gas, it starts to vaporize. Now, in the instance with our closed container with the water being poured over it, we have to first understand that marker. Okay. Gay-Lussac's law, which can be illustrated as P1 over T1 equals P2 over T2. Now, in other words, the relationship between pressure and temperature is proportional. So if you were to raise the temperature in a system, the molecules and particles will move more rapidly, the pressure will increase. If you lower the temperature, the inverse effect happens, the pressure will go down. And we also have to understand that the heat capacity of water and air are different by a degree of 4 in magnitude. Approximately 4.1 or 4.3 or something joules per gram degree Celsius, as opposed to approximately 1 joule per gram degree Celsius. Not exact values, but approximately. So when you have a closed container with the water boiling, you pour cold water over the system because, I put 2 A's in there. Okay, great. Because of Gay-Lussac's law and the fact that air has such a lower heat capacity than water, the air will cool off much slower. Right, that's what this means. It requires more energy to change the temperature of water, so the energy is going to escape the air, it's going to cool off much faster than the water. This causes the pressure to go down. So in a system where the vapor pressure and the atmospheric pressure were equal, it was boiling, now all of a sudden the atmospheric pressure, the pressure of the air is much, much less. Therefore the vapor pressure proportionally is much stronger. Therefore it's going to boil much more vigorously because the force pressing down upon the water is significantly lower, while the water is still very hot. And so the vapor is going to escape much more rapidly, it's going to boil much more vigorously. And that is how this phenomenon happens. Thanks.